for joining us today for this session of On the Edge with Lfh webinar series. Today we're going to be discussing Home Edge, how your home devices get deployed in an edge computing services ecosystem. So I'm going to go ahead and introduce our speakers. We're going to kick things off today with our GM of Networking, IoT, and Edge, Arpit Joshipura, here with the Linux Foundation. And our main speaker is going to be Suresh LC. He's a Senior Chief Engineer with Samsung. We also have Munki on the line with Samsung, who is going to be helping with some Q&A. So just a couple of quick housekeeping items, and then I'll turn it over to Arpit. Attendees will be muted during the presentation. However, if you have any questions that arise at any time, there's a Q&A window at the bottom of your screen. So feel free to click on that and type in your question. Time allowing, we will go through those live towards the end of the agenda. If not, we'll be typing responses throughout the presentation as well. Here's a quick agenda. Arpit's going to kick us off with the Lfh overview, and Suresh will take on the remaining items. We also have some fun videos, so you'll definitely want to stay tuned throughout the entire presentation. All right, so without further ado, I'm going to turn things over to Arpit, who is on mute.
Thank you, Jill. All right, so I am just going to take a few minutes to give an overview of the context of Edge and how it's narrowing down on the top application use cases and Edge deployments, and then give a quick update on terminology, and then see how important Home Edge is as part of the entire Edge revolution that's going on. So if we go to the next slide, there's a lot of analysts tracking a lot of things, right? But here's a KPMG view that basically says the top 5 markets that are going to take advantage of Edge. And remember, for those of you who are not familiar with Edge computing, it's moving storage and compute closer to the applications as possible, preferably in the 25 milliseconds latency or less, right? That way you get very quick response for apps, and a whole new set of markets come in, preferably on the home side or on the enterprise side. So the top 5 markets: industrial, manufacturing, energy, commerce, and then homes, right? Which includes B2B2C as well from a use cases that you will hear about today. And then of course, automotive, fleet, etc. So a huge market, and according to a couple of analysts, edge computing market is roughly 4 times the size of cloud computing. So very important to pay attention to this, and there's a whole new revolution going on, especially now that we are all sitting in a home remotely during the pandemic. So if you go to the next slide, there's one thing I want to say, which is in the last 3 years, there was confusion about what is an edge, right? And terminologies were thrown that were completely incorrect. Thin edge, thick edge, far edge, remote edge, right? They were all relative terminologies, right? It depends on where you are in terms of your location. So what we have done at the Lfh level, if you go to the slide showing it, is we have defined terms that are absolute terms, right? And this is a community-based definition. So it's not vendor specific, it is global definition of the edge. And these terms are approved by a community project called State of the Edge that Lfh hosts, right? So think of it this way: there's a user edge and there's a service provider edge at the macro level. User edge is dedicated and operated, service provider edge is shared and as a service. And then if you go inside, you have extremely constrained device edge, right? So these are microcontroller based, embedded compute. This is where a lot of the home type devices fit in. Then there's the smart device edge, which is where we will discuss today's project about, right? Which is mostly like around a gateway or set-top box or whatever. And then there's on-prem secure location edge, right? And then there's a last mile that separates edge from the access and smart central office, where you're now getting into the service provider edge. However you look at it, we want to make sure that we understand that IoT is a big portion of edge, but not all IoT is edge. And similarly, telecom is a big portion of edge, but not all telecom is edge, right? So there's all these intersections. The common thing is proximity of compute storage, responsiveness, and mobility. And that's kind of the fundamental basis of this framework. So if you go to the next slide, I have overlaid the projects that we host under Lfh here on this slide, and they range from infrastructure projects to application projects. And you can see Home Edge right smack in the middle. It's the seed code and the contribution came obviously from Samsung, who's one of our premium members here for Lfh. But the other projects kind of span the edge computing space, if you may, whether it's infrastructure, whether it's applications, and they are aimed at a specific use case in a specific market. And that's kind of how we look at Lfh projects. Our goal at Lfh is to unify the frameworks that sit across the cloud, the IoT, the telecom, and the enterprise edge and the home edge markets, right? So that's kind of the overview of these things. If you go to the next one. What I want to show here is edge does not sit alone or standalone. It is in context with other open source project from an end-to-end perspective. And then at Linux Foundation, we are simply hosting projects which go into products that get into deployment. That's your circle on the right. But then if you look at the access side, so there's a mobile network with ORAN as a host project, or the residential with Home Edge. Or then if you look at enterprise and industrial, you have Fledge and Eve that come into an edge computing sort of a service provider edge, and then they go into the core, both public and private clouds with projects like ONAP, OPNFV, Kubernetes, etc. And at Lfh, we're working very closely with ETSI, ACC, IIC, like a lot of these, as well as from a home edge perspective, Suresh will walk you through some of the standards and some of the collaborations that we have done. But effectively, harmonization of standards and open source is a key part of what we do here at the Open Source Foundations. Okay, all right. So I think there's just a few use cases that everybody looks at. I won't go into the home edge use cases. This is the webinar for that. But if you look at some of the other projects, there's everything from connected vehicles to augmented reality classrooms to private LTE to cloud edges to building automation to predictive maintenance of turbines, transformers, pumps, etc. So very, very powerful use cases and real world applications that is driving this edge computing market. Okay. And one quick couple of slides on the Lfh community. We are growing very significantly in terms of projects, new members, deployments, downloads. You can see the graph on the right, both year-over-year developer growth and year-over-year commits have gone up significantly. The main reason is people want to collaborate, people want to innovate, and they want to create a market for solving these problems very, very quickly so that they can get to revenue. So we're excited about this and excited to have Home Edge as an anchor project. All right. I think with that, I'm just going to wrap up by saying Lfh is, again, harmonizing the edge framework across IoT, enterprise, cloud, telecom. And then the general principles of Lfh is it's independent, it's open in hardware, silicon, cloud, OS protocols. It's bringing in collaboration with consortiums, and think of it like a similar umbrella like any other, right? CNCF, LFN, etc. So that's kind of Lfh. If you're not already participating in this, it's very simple. Go to Lfh website and just sign up. That's it. All right. So with that, I think I'm going to pass it on to Suresh, who will get you into the details of the Home Edge project.
Yeah, thank you, Arpit. It was indeed a good session on the overall of Lfh, the projects under the Lfh umbrella and the various use cases. So as Arpit had told, we are representing from the Home Edge. So myself and Monkey are over here from Home Edge project, and we'll walk you through Home Edge project, how it has been, how the seed code was brought into, and where we are now, and how we are thinking of going forward ahead across. So what was the motive for Home Edge? creating a home edge platform. So going into it, so we wanted to put across some facts which are there on the existing system. So if you can see over here, this shows a number of smart home devices. From say the doorbell on the front of your door to the bathroom geysers or the lights, the ambient lights, the appliances, the refrigerators, washing machines, oh, so many. Name them, you have this, yeah, they are now smart. So smart in the sense they are so smart that in a item goes out of stock in your refrigerator, it gets added into your online cart. So all these have become smart, but going forward, how smart are they going to be and how fast they are going to execute? So there are a few challenges on these. So much data is going to get generated from these devices. So when data is getting generated, the current existing system relies mostly on the cloud infrastructure. So all the data goes ahead to the cloud and it gets processed over there and the response comes back to the edge system. So as you can see over there, there's a latency in the processing when it goes into the cloud. So and you have the different devices are from different vendors, OEMs and all. And as it has been pointed out, LFH is for a vendor friendly and it is more open. So that is how we are coming into the play. So for every 100 miles, there's a latency of 0.82 millisecond. But when you're in front of your door and you're trying to open it and the camera is not recognizing you and it is taking time, you feel irritated at times. So there's a need for the computing at the home environment, home system. So at the same time, if you can see the data from an Ireland, which is shown at the data privacy, you can see that many people, they do want smart home devices and they want their home to be smart. So what they feel more better is 80% of 81% of them feel it is makes their life easier. But at the same time, more than half of it, 52% feel there could be a personal data theft. So data which is generated a lot around the home devices, that's the most important thing and the most easiest to be breached upon. It has costed many companies, like if you see in 2019, it has costed the data breach has costed all the companies to nearly together $6.45 million. So it is not it is a huge amount. It is not a small penny. So data breach and latency, these are some of the key points if you see in existing home environment, smart home systems. So all the smart home currently, the OEMs are from, the devices are from different OEMs. They have the different cloud infrastructure in different regions. Few have there in APAC, few in North America. So the latency comes and it plays its own role. So going into it, into the next slide, we will be seeing next slide. So we are seeing over here the growth of the smart home devices. So that in smart home, we have various devices from say the appliances like the refrigerator or the washing machines and all, to the smart energy meters are there, which try to minimize your energy bills, and to the entertainment system, which was the initial devices which came into the home system. And then the security, which is now playing the most important role. So there's been an exponential growth if you see from the 2016 or 17 to current, how it would be projected in 2022. So the number of devices would be proliferating a lot. So, and all these devices, they are mainly two things which play the major role for them. That is local data processing, which helps in reducing the data privacy and have more security. So having whatever secure workloads to be done at the edge node, at the edge computing device itself, rather than having it sent to the cloud infrastructure and getting it done. Next thing is latency. So reducing the latency, getting it more real time, getting the analytics more real time. Now it is a world of AI and machine learning. So name it any device, yeah, they have an AI module in it, and this AI module, if it going to go to the cloud infrastructure, relies on a cloud infrastructure, it is going to have its own time. So I would say that we need to have a part of the AI at the edge device itself. I wouldn't say a complete whole AI would be over here at the edge, but a part of the initial inferencing is what I want to say should be at the edge. That will give a more real-time IoT and analytics data. So into the next slide. So we have seen some of the drivers for the home edge. So mainly we need to, there are various different devices, different vendors are there. So all these vendors have their own platform, their own APIs and all. But this, when it comes to device interoperability, it creates an issue. So we need to have a common platform, and Lfh and HomeEdge kind of a platform which is open and which can be adopted by any of the vendors is what we are trying to think upon. So a common API, common gateway, and common lifecycle, common management of services which are offered by these devices which are there in the home environment, and how to manage these services at the home environment. So device management, service management, or these are the key features which we need to see, which should be there in a home environment to make the home, a smart home, more better and more used by the any user at the endpoint. So data storage and the latency, as always for in case of industrial environment, we know that in industry there's a lot of data which is getting generated. So always the general industry smart in devices industry itself has concentrated more on industrial intelligence and stuff, and edge computing over there. But in case of smart homes, it is proliferating, but it is on a going on a, it has in the past few years it has been a growth has been less, but we can see it has started to grow in a very good manner, exponential manner now. So we think that home edge also needs its part of piece of meal for making it more available and more adopted by the users, and making their system relying on their edge computing systems more better. So we feel these are some of the drivers for making the home edge and making the say the smart home more better for the user perspective. So going into the next slide. So these again have put across some of the devices which we can see that say we have all of us know about the smart locks and stuff, but most of the smart locks currently rely on their cloud infrastructure. So say the smart things app which is from the Samsung is there, is also compatible with the AL lock, but the smart things app in the from the Samsung, it has to connect with the cloud of the AL system, which can be in North America or somewhere, to get the data of the AL, to get its status and get it updated onto the SmartThings app. So everywhere it goes into the cloud and comes back into the say the user's app, or it comes back into the say allowing the user into the home. Even the camera, for example, nowadays camera is very proliferated a lot. Blink from Amazon has been very extensively used. Initially they were for the external surveillance camera. Now they have started doing it for the indoors also. So the camera has become more reliable, more important for everyday's human life. Like how a mobile phone had to be 10, 20 years ago, now cameras are on playing the same role, like they are the bread and butter for every home. And now in the situations like COVID, where health is more important for all of us, we are trying to capture our health data. So every home is now, every other home will be having a smart thermometer now. So that has become a default, and an SpO2 meter. So all these are also smart devices again, which try to send you data. And health data is most important and most private data. There's a HIPAA compliant, whole HIPAA is running back at the back end to make it more secure and more privacy for maintaining the health data. So this is another important thing which is very widely used in the home environment. And every other house now has a Google Home or an Alexa. So everyone more speaks to the Google Home or an Alexa rather than to the other partner at the home. So initial stages of Google Home or Alexa, if you see the ASR and the NLP processing, how they have been is they relied on the cloud. So all the whatever speech we have, say, hey Google, goes into the cloud and then gets processed and then comes back for the command whatever we had put across. Be same with Alexa. But of late, I do accept they are also trying to come into the local execution mode. So they also see that it is taking time. There is a latency, and for user now, time is more important. They feel they need for any query, any action, there should be a response immediately, and it should be the most real time. So this Google Alexa or the Google Home they are also doing a local execution of the voice commands and trying to see to execute, say, switch on living room light. Now the Google Home does it locally instead of sending it to the cloud, and from the Google Cloud to the partner cloud, and then sending the signal to the device to switch on. So everyone is trying to do it more faster, more efficient, with more data privacy. Hence, these are all we can see that there's a need for home edge, and home is the most smart home is becoming more prone to these data breaches. But at the same time, how can we make it more robust, more better for everyone's use? So that's how we came into the home edge. Now we will look into the home edge details in the next slide. So is home edge the only platform would be a question when any user comes into play. Like, why should I take only home edge, or is it the only solution available? I don't say it is the only one. We do have various other solutions, but for the home environment kind of stuff, we could say that home edge is one of the seed platform which is started. But though Greengrass on Azure or a Google IoT Edge, these have been very mature when compared to home edge. You can see they have started being from 2018, and they are in a more mature form. They, as it goes, and Amazon Greengrass has its own cloud infrastructure, or be it with Azure IoT Edge. So they do have their own cloud part of it, and the Google Cloud. So they have a good cloud infrastructure, and then the corresponding the edge platform for it. So both of this goes hand in hand. Though I say edge computing and we are on the edge, processing everything at the edge, at the end of the day, processing completely at the edge is not going to be the complete solution. But what is it processing at the edges? For the immediate inferencing. So for further inferencing, for the further fine tuning of the model and stuff, we do rely on the cloud, because the edge, the home devices are not so capable enough. Capable enough in the sense memory constraints are there, and say the bandwidth constraints are also there still. But going ahead, these would be going across. Now smartphones are becoming more powerful than even the older laptops or so. So I do accept they are getting, but the cloud infrastructure is also correspondingly growing, and they do have their own benefits. So both of these two go hand in hand. But for the immediate inferencing and immediate response with latency and privacy, the home edge is most important. I mean, edge computing at the home is most at the edge, at the endpoint or the leaf node is the most important thing. So also when data is being sent in, say in the olden days of sending the data to the cloud, the whole data, the image data, complete image data used to be sent. But now we don't need to send the complete image data. Instead, the inferencing from the image can be taken, say the iris position, say the nose position, only these, whatever the key differences between the previous frame and the current frame, for when we are detecting some motion, can be sent to the cloud. So thereby, this reduces the data which is getting sent to the cloud, as well as reducing your bandwidth, and there's a less latency issue. So we see that there are the need for the home edge is more important, and computing at the edge is more important. So Greengrass, Azure, and IoT, as I mentioned, they are all very mature enough. They do have their cloud infrastructure support for them. But few things which they more concentrators for them, there is only a single edge device which is at the end, and all other devices are the leaf devices. Say like in Azure, IoT Edge, it supports a single edge runtime, and other devices are leaf devices which can connect to this edge device. Whereas our whole, so this is more like a primary secondary kind of an topology. Whereas our home edge, our approach and idea has been like a D2D. So device to device communication and device to device discovery, and doing it at the device level itself, at the home network level itself. So this is one of the few key point, which was the initial starting point where we had thought we should be differentiating from others. That is the compute offloading. So our main motto, with which we started this, was offloading a service from one device to other device based on the compute. We'll be seeing what I mean by compute offloading in the coming slides. So in the other key feature which we see is multi-net support. So when devices are in different NATs, say it has become such that now in a single home environment, we have multiple routers. So one would be a primary router and master router, and other routers are secondary routers. So devices which are connected to the primary are not able to discover the devices which are on the secondary router. So this exists in in current system. So we got as a VOC in one of our discussions. So we thought we should also try to answer this question. And so we have that VPN solution, which we are bringing it this year. So we'll be seeing about this also in coming slides. So this shows that how we stand across with other existing edge and platforms, and how we are trying to grow far ahead and then compete with each them and compare. Rather than to say compete, I should say we are trying to be a companion with them and see how well we can do together as a single edge platform. So we have seen over here how home edge works over here, and we are just compared to these systems, we are just started say in 2019, and we are into the second year, and we hope to do a very good from in the coming year. Going into the next slide. So I would have given a brief need for home edge. So home edge now needs to then answer the questions of use cases from the home perspective, then architectural and technical requirements. So these are we need to define these as an home edge project. So we thought about it. Then we need to be vendor neutral. So we need to define APIs which are vendor neutral and which are not OEM specific, and make the use cases requirements and blueprints so that they can be adopted by any vendor. And next is collaborating with other projects, open sources, which are there in our home edge, under LFH. Like currently we are working along with EdgeX Foundry. So going across, how about making a blueprint with Acrono, or few of these things, or some of the things which we are trying to move ahead for the next coming years. So these are some of our high level scope from technical home edge point of view. When this scope boils down to a technical requirement, main thing is, as I mentioned, device to device discovery, device to device discovery, and service discovery. Discovering various devices which are there in the same home environment. Also, what are the capabilities? Capabilities can be from the hardware perspective as well as from the software, that is service perspective. So finding these services and devices. So once these devices are found and say computer offloading is done, or hands are not done, we still have something called as the quality of service, because at any point of time a device can go down. Say a mobile phone had been processing some person detection method, but say the mobile goes out of the home network range itself. Say the user moves out of the home. So how well we guarantee the service of quality of service out here? So that is another key point, which you would be seeing even in one of our demo, which we are going to showcase in the coming next slides. So this is another quality of service, is another technical point which needs to be handled. Then is any platform now is incomplete, they say, without the machine learning module or an integration. So a distributed machine learning has become a bread and butter now for any platform. And that too, for an edge kind of platform scenarios, the machine learning plays a very important key role. Say like from the surveillance camera, detecting a motion, detecting a theft, or detecting the camera anomaly itself is more important. So everything from the home edge plays an important role. So as I mentioned, when multi-vendor interoperability or vendor neutrality and user privacy, these are all some of the technical requirements which we are trying to capture one by one and bring it into this home edge platform to make it more complete. So next we'll see like how we have been doing our achievements in the next slide. So as I mentioned, we started this somewhere around 2019 when our first initial seed code was done. So at that point of time, our first seed code was discovering the devices which are there in the home environment, and then discovering the services which are there present in the home environment. So that was our main motto of the project. So there we started with device discovery and service discovery and sharing the resources across the devices. Sharing the resources across the devices means how well I'm able to offload a service from to one device and try to get it compute offload to the service device, and how is it able to perform the module and then get back the result from the device. Say for example, a home camera, a surveillance camera is there, and it is trying to detect a motion. So, but it is not, it doesn't have the motion detection, say a person detection module in it. Instead, say a TV which is there in the same home environment has the person detection module. So can the camera use the person detection module of the TV and detect who the person is, and automatically once it is detected the person, and if he is an authorized person, automatically send us a signal, a command to the lock to unlock the door when the user is on the front of the door. So how well I can use the resources intelligently among the devices which are there in the home environment and do it. So that was our initial motive when we started with the home edge orchestration and the Baobab, or the first version of code which we released to the community. So once we have done the device discovery is done, devices generate a vast amount of data, lot of data. So data is now the key for any, say the MA or the ML, data is the basic. So data is the bread and butter now. So how well are we going to use the data? If we are not trying to use the data, it is going to there again go into the OEM's cloud, and we are going to be silos in a platform in silos. So we thought of having a module which will try to capture the data from the various devices, the various sensors, be it a HVAC sensor system, a motion sensor, whatever be a light sensor, whatever be it. So whatever devices are there in the home environment, try to capture the data from these devices and have it in a high-end system which has a higher memory capability. So there we thought, okay, data storage has to be a need of the hour. So we had the data storage as one of the key deliverable for our this year 2020. And then in one of the VOCs, when we had that there are multiple routers and discovering devices between multiple routers is causing an issue, we thought we need to address this, which this could also be a key role, because when a device which is there in a sub router and is not discoverable by a router, by a device which is there in the main router, primary router, then our whole compute offloading itself goes off, because we are not able to handle the situation. So we thought multi-net device discovery is also one of the key features which we need to target for this year. So these two are our key features, and which we have completed with the development and all stuff, and we are in the process of releasing it into the community. By this year, by in October, we are going to release it for the community, and we do welcome people to check it out how it is. So this would come as a part of Coconut release, which we have planned for October 2020. So we have got the data now. We are able to discover devices, be it in a single same router or different routers. So what next? As I mentioned, the ML module or an inferencing engine is the next key thing when we have the data with our hand. So dynamic service deployment from the cloud and dynamically managing these services. The service deployment is one, and managing the life cycle of the service is another important thing. So how do we do these? So this is our one of the key targets which we try to do for in 2021 and break. So this makes the whole platform a more complete platform which can be adopted, taken up by any. It will be by any vendor, and it is more like vendor neutral. So anyone can take it up, and it can be used, adopted very easily. And with this, we can also make more effective blueprints and use cases for smart home devices, smart home environment, and use scenes and automations. So we hope to have a complete platform by next year. So this gives a more how we have been growing from 19 to 20 and how we are planning to go ahead with 21. So next we'll go into the details more specifically into the next slide. So homage base code, as I mentioned, for the Linux, it has been released as part of Baobab. So data service discovery, the device discovery, these have been the key part. And the interaction between the devices, it has been as security becomes a more important role when devices start talking to each other. So HTTP TLS security is also being supported by the base code in Baobab. So multi-edge and the data storage framework. So multi-edge, to give a very brief, what is the problem statement is, there's a primary router, there's a secondary router, which is connected to the primary router. A device which is there, and say a device is connected to the primary router, and another device is connected to the secondary router. a device which is there on the secondary router can reach to the device which is there on the primary router, whereas the vice versa is not applicable, because in network terminologies, a device which is connected to the secondary router will talk to the secondary router. Secondary router, it is not able to find, say, IP 10.1.1. So it immediately pings to the router, to the device which is on the higher level in the network layer. That is the primary router. So when it talks to the primary router knows the device which is, because that device is connected to the primary router. So it is able to traverse from the primary to, from the secondary device which is in the secondary. Whereas where the problem is for the primary, the device which is on the primary router. Say the device A which is on the primary router tries to connect to a device B which is on the secondary router. It first talks to its router, that is primary router. Primary router doesn't know this device. Though it might need it might know the IP, it cannot come down into it. It will be moving in the network transport layer, network layer communication. It goes into the next level higher. So it goes out of the network layer. So it doesn't find the device. So it becomes a problem. So we try to solve this by having an intermediate and a local server running, and a local server assigning virtual IPs to the devices which are there on all the in these routers. And this broadcasted IPs or these virtual IPs are broadcasted to the various devices which are there on the in both the routers, thereby making the communication possible between all the devices with the different routers. So that is a multi-edge communication which we are trying to solve. And next is the data storage framework. In our initial code, we wanted to have the first base communication setup. And next, so we wanted to have a data storage. Developing a whole data storage is not, it is not that it can't be done, but always in open source, it is good. We start collaborating, make the, it is more, we be a companion with other projects, and we try to leverage the best of the other projects and try to make a more better use cases. And in this part of it, EdgeX Foundry seemed to a very good candidate for us. We too did some of the various other candidates. We studied, checked the feasibility, and EdgeX was very open, and they have been very helpful in our queries or whatever point of view. And it has been a very complete platform even. So we had collaborated for EdgeX because EdgeX out of the box provides the MongoDB, Redis DB now for managing the devices, as well as the device data from the various devices using the core data and the command and all. So we have collaborated with EdgeX for data storage framework. Going to the next slide. So this is the Baobab, or the last year what we have released to the community. So device discovery, application discovery, and there is something called as when two devices are going to have same device, same services. How am I going to offload a service to the which device? How do I do it? So we thought we should have some amount of scoring, which will help me to decide to which device I can offload my service. So we do have a module called as the scoring manager. Currently, the scoring manager, I would say, is very primitive, but we are planning to work on it also. We even have done a POC on it. So our scoring manager, to give how it does is, it's a formula based. Basically, it uses the processing, the CPU processing of the devices, and then it uses the memory what is available, so that if a service is getting offloaded, will that memory be available, and it can it be used to compute the whole service at the network bandwidth. So these three have been our current formula, which uses these three as the parameters to decide on which device to offload. But I do understand, say though a device can get a high scoring, but say if the device gets started, is being used in the next moment of at the point of time when the offloading happens by a person, by the user, then it becomes difficult. So a dynamic, a more adaptive, or a learning, self-learning method of scoring is needed. So might be a time series based, or we are working on various methods of seeing this, how well we can make the scoring manager more dynamic, more effective. We do support Android, TLS communication between the devices for the messaging. And so we have done a sample service offloading for a distributed web engine internally over here. So we can get the GitHub link and the wiki link are given over here, and community can have a look on it for further details for Baobab. Into the next slide. So here I want to come bring upon some of the technical aspects which we have thought. So for the service offloading, as I mentioned, the scoring manager is one of the important things. So currently it is CPU, memory, network. So these all play the important role for me calculating the score. Based on the score, which device gets a more higher score, the service is going to get offloaded. Based on that, the offloading happens and it goes into picture. So starting when we had started this project, we had like in those initial stages, we thought Java would be a more better approach for developing this platform. But we felt Go did overrule Java in few important aspects. Home edge devices or memory constrained devices. So the execution has to happen, and the machine it needs to be a very small footprint. The platform needs to be very small, and hence the footprint of the platform should be very small. So, which makes the execution better. So for that, we felt Go has better thing. Similarly, if you consider memory management, Go doesn't have references like Java, but it does have pointers. So it makes the things more better, more easier, and more straightforward. And it has the orthogonal features which makes the language more simple. And if you even see the Go man help, it is more short, smaller. So commands are more clear and straightforward when compared to a Java, which is a more than 200 pages of documentation. So Go seems to be a very good candidate, and I do feel every other open source or any edge project, they do rely on Go, and Go is becoming the more better platform language for developing any platform. So here I wanted to bring in these technical aspects over here, and now we will see into the architecture in the next slide, a high-level architecture of our whole home edge platform. So here we can see the various modules over here, like the edge orchestration, data storage, home device control, machine learning, and stuff. So edge orchestration, the base or the bread and butter of this platform, that is device discovery, service discovery, and device management. So this was part of our whole main module, which we say is the edge orchestration, which we released to the market last year. So data storage is the next part. We have here we are using that core data, metadata, and command from the EdgeX Foundry, working along with them to have it have the data more into the save the data into the DB MongoDB. Currently, we are using MongoDB, and we are planning to shift into the Redis, which even EdgeX is recommending. So we are working on those stuff. But for Coconut release, we are going to release with the data storage also. So these are now devices are in silos there at the home environment alone. So we need to make them talk into the cloud infrastructure to have more better coherence and more better usage of the device. Else the device also becomes overdone over the period of time when the machine learning model is not updated, or say when the machine learning model is not fine-tuned. So we do need a home device control, which is nothing but a cloud interface into the cloud for the cloud infrastructure from the home system. So that comes into is one of our next key things in our next bucket, which we are trying to add upon into this platform. And as I said, machine learning is the next module, and we have already started working on. Samsung has one of its machine learning, Samsung One NNA is a neural network framework. We are trying to see whether we can integrate with the NNAs or the TensorFlow from the Google. So we are considering various options, but we have started to work on these ones with after the Coconut release. We are targeting to work on these points of it to make the platform more complete and stuff. And we do understand current home edge supports only IP-based, REST-based devices. So we are seeing a chip which is MQTT and chip. MQTT has been already proven method, a publisher subscriber method, protocol for communicating. So we do plan to see if we can incorporate the MQTT so that more broader devices can be brought into the home edge into our platform. We can cover more wider amount of range of devices. And then chip, which is being into the next most spoken about in this industry. So we do think we are evaluating of adopting to chip also. So these are some of the things which we are thinking on, pondering, like how well we are going to do it. So this gives a high level platform architecture of home edge. Into the next slide. So these, just for the technical people who are more inclined towards the technical aspects of the project, so we have categorized, we have our modules into our code itself has been modularized into these buckets, like discovery manager, which helps in discovering the devices, using the network manager, which is the basic NAT traversal manager, which is for the NAT, traversing to the NAT for discovering the devices. Then a configuration manager, which is nothing but the capability, the services which are going to be given by the devices. So we do define the schema of how the devices expose their services. So we have given all these details in our wiki page, which people can check on it on our GitHub link. So what is the schema? How is the service is going to be exposed by any devices? Then the scoring manager, which plays a role for offloading. And then the most important one is the orchestration API, which is going to be used by the end application, a developer application, to offload that the service to other device. And the storage manager or the MNDC are being added from as a part of the Coconut release for the coming this year's release for home edge. So storage manager for the data storage point of view, and MNDC, the MNDC server, which is going to run to allocate the virtual IPs for the devices and traversing through the multiple devices which are in multiple NATs. So these are the various components, and mostly this would be for the people who are into the technical incline towards checking on the modules. So into the next slide. So releases, Baobab has been the most, I would say, a more advertised into the community in the last year, which has been a complete one. But we had a pre-release, like an alpha release in the month of June last year, which was just had the device discovery. But I wouldn't say this is very good to take this alpha release, because when I said privacy is the most important, and when it doesn't support HTTPS or TLS, it is going to cause an issue. So I would always recommend a Baobab to be the, I would always talk that to be my base release for any version. So Baobab had the complete security and TLS for the communication between the devices and stuff. So Coconut, which will have the NAT and then the data storage with the EdgeX Foundry. So every license, it is an Apache 2.0 contributors now, Samsung has been a key contributor for this project, and we do look forward for more users, more community members from the other projects also to help to contribute into this, and we are open for it, for new features or working along with us for the existing our roadmap. So into the next slide. So this gives the numbers and where do we stand, how well we are. This is just for the past month's data, I could say, like how we have been. Like for the seed project which had been seed coded last year, we are going on a good, we had been from the gone into a growth stage from the impact stage. So, and we are trying to from the at-large to the growth, and we are trying to march ahead to the impact. So how well for it. And I think making it more complete as a platform, and then building use case for the blueprints would make this project a more into the growth or the third stage of more mature stage project. So these are few numbers which you can see for yourself for like how well we are, and how for the devices for more smart home kind of devices systems, they're very memory constrained and very effective. So into the next slide. So when our system is very complete, is fully complete, how does its system look into is proposed over here. So say a live feed from the camera comes, all the devices are going to run the edge orchestration. All the devices are registered with the device manager, which is having the metadata for for the device profile, and the context manager for the sensor data. So whenever a user comes at the in front of the doorbell and he sees the camera, the doorbell is not able to do the person detection, but it does understand that there's another device which can do inside the same home network, say the TV inside the same network. So it sends the camera feed to the through the device manager into the TV, which has a rule engine to process the image and say whether you can and send a signal to the lock whether it can unlock or it should not allow the person. So this rule engine again, or the ML framework, would be communicating with the cloud to synchronize the weight and fine tune the model and do stuff. But these are not currently existing. But as I said, this is what we are looking upon when it is a complete platform and how it should be looking on. So this would surely urge any user to adopt to our system and take our platform as a complete platform and easily use for them. So this is a complete platform which we are thinking upon. Into the next slide. So we wanted to see how well we are going to play. So did a small play around along with the Azure IoT Edge. Actually, we don't have an edge runtime kind of stuff with Home Edge. That is one of the things which Azure or a Greengrass or stuff who has their say they're more positive or the stronghold of it. So we thought how well we can co-work with them, like use that feature, the IoT Edge runtime capability of Azure, and see how well the Home Edge can be a companion and work along with this. So we wanted to demonstrate a small use case of, say, detecting a persons in a room based upon the number of persons, changing the HVAC temperature to either increase or decrease. So for this, we use the base device is going to be a camera device, which is going to detect the, which is going to feed the live image video frame. And then we had a Jetson Nano device. It could be a gateway device kind of stuff, which we are wherein the edge runtime is going to be there. So the edge orchestration module is going to be deployed from the Azure along with the data aggregator into the Jetson Nano device. That's how we did it. So it was a small POC device, or POC how we what we demonstrated. I'm just giving an idea of what we did. So the camera device is going to send the data to the edge runtime, and it basically what it does is it finds that there are two other devices, that is say a Linux laptop and say tab or stuff which is there in the home, and which can do a person detection, number of persons from this image feed. So it does a compute scoring manager, it does a scoring, and it offloads to the appropriate device. Say for example, the Linux overrules the tablet, it sends the data to the Linux, and Linux sends the data as how many number of persons have been detected to the data aggregator. So data aggregator, every 5 seconds, it is going to send the data to the mobile. Here we have shown a mobile to mimic a HVAC system. So just to say that number of persons is 5. Previously it was 2. So now decrease the temperature to maintain the same temperature. Or say if 4 persons have moved out, it is only 1 person. So increase the HVAC can be increased. So this was a small play around which we did along with Azure IoT Edge, and we wanted to see how well we are with that. So going to the next slide. So we'll see one of the global presence, how Home Edge has been. We participated in IoT World Congress in 2019 in Barcelona, and we demonstrated a use case, that is anomaly detection. So in home system, when an anomaly is detected, how well it is going to be. Now we'll see the demo use case video of it, so that the video will speak for itself first. The video.
We would like to demonstrate a scenario how the edge computing can be a useful tool when we talk of a home scenario. Inside the home, if devices contain an edge layer, they are easily able to interact as they become discoverable. Whatever services they are running can be rendered upon any device, and we will see how the power of the edge can be utilized inside a home scenario. We are for the current demo, we have set up an intrusion detection system where a CCTV camera has been set up, which has been demonstrated by a Logitech webcam. We have one i7 laptop. The i7 laptop is running an AI client. The exact same AI client is also running on a mobile phone, which is an S9 device. For any user output, we are showing an app on another S9 device. This can also be an Android phone or any other device which has a screen, maybe a TV, washing machine. We have set up a dashboard. The dashboard is to show vitals of the mobile phone and the laptop to show that how the tasks are being delegated by the edge. This also makes us understand that how the edge is working. We'll be trying to demonstrate that how usage of edge computing can help us in improving latency, bandwidth, and privacy. For the current scenario, whenever the CCTV camera is blacked out, because we have AI instances running inside the home only, we are trying to harness power and therefore run whatever processing that the AI needs to do inside the home, maybe on the mobile or on the laptop. We are not sending any data on the cloud, saving us from latency, any bandwidth issues that we might face, and also the privacy concern of sending a home feed to the cloud. We would like to demonstrate this with the demo. For the first case, we will just try to make an intrusion on the camera. So let's say there's a thief that comes inside the house and covers the camera. As soon as the camera got covered, we see that here we got a notification where the app is launched. If we try to play, so we see that there is a person that came to the camera and closed it. We also see a message saying that the camera is out of focus or dirty, which is an output that we received from the AI agent. Currently, we can see that the AI agent that was selected was Linux and not the Android phone, because reading the vitals, the score of Android is very less than the score of Linux, as this is an i7 machine. Whenever we try to make an intrusion, in all cases, the Linux system is being selected as the score is really high. Whenever we get an intrusion on our end device, we see a notification saying that camera intrusion has been detected. Clicking on the intrusion, we can get into the app telling us whatever is the problem with the camera, and also being able to see the video. We've also tried to maintain a history where we know that what is the problem with the camera. It is out of focus, it is dirty, or it is blacked out. For all the instances, you can see that whatever is happening with the camera through a video instance also. The app gives you a notification whenever there is an intrusion, and the phone is also capable of running whatever the Linux system is running. Let's say that I take my Linux system out of the network. In case of mobile, we can, if my mobile was processing something, maybe I just got out of the network, so somebody else has to process it. In this case, let's say when I close the camera, as you see, when I close the camera, Android has been selected. There is an app running on the Android, a service running on the Android that is processing, analyzing, and giving the feedback back to this viewer app. We have received a notification here. Click on the notification. We can see that what is the intrusion that took place. Plus, we also see that the camera has been covered or blacked out. This will be a permanent storage also. In the video repository, you can go and see all the previous intrusions that have taken place. If I bring my Linux system back into the network, and now I tried to cover the camera. So my Linux system will be selected and all requests will be delegated to it, as it is a more powerful machine. I will receive a notification that intrusion has been detected, and you can play the video again and see that whatever is the output of the AI. We also want to project one more case scenario. That the scenario being that what happens when a request is delegated to a machine and that machine moves out of the network or becomes heavily loaded or crashes. In those cases also, our system is capable of redirecting the request to some other machine. In this case, we would like to demonstrate by sending a request from the camera to the Linux machine and in between of the processing crashing the machine. We would see that the Android triggers up and would process the output and give a notification on the end device. So in our case, we'll go and we'll turn off the network only when the service request has been received. So service request has been received and I'm turning off the network. I've already got a notification saying that intrusion has been detected. Network has become unreachable, but the Android has started the service now. Video is being analyzed and the output has been sent back. Whenever I open this notification that I had received, it processed normally and the user will never know that some device moved out of the network or some other device had processed it. Let me get back into the network. So we're talking of a case when there is only one device in the network and maybe I moved out of the network and came in back. So this device will continue processing right from where it stopped and it gave back whatever result it should have. And on opening the app, we got a notification saying intrusion had been detected at a previous time instance. And same video that was processed on Android was being sent by Linux. This has been done to make the system more robust, as all failures are redirected to other systems, and in case there are no other systems, the process starts exactly from where it had stopped.
Thank you. So we have seen the use case of what we have shown across in anomaly detection in IoT World Congress in 2019 at Barcelona. So basically anomaly detection and then using it. So at the same time, you could have seen that quality of service is being maintained over here. Even though a device goes down, we are able to do it from the another device which is there available in the same network, and we are able to do it. Going into our the next, what is our road ahead and what we are thinking of in the next slide. So I've given a high level, like what could be a broad, what would be there in our plate of things to work upon. See, a broader protocol support, which I've already mentioned, to make more wider amount of devices available in the market to be like the MQTT based or the chip, which is pitching up in the market. Then a centralized management of devices. Currently, when MNDC server I say is going to run, so there's a centralized management. Similarly, when data storage I say it is going to be centralized management. So when these two are centralized management, how about making the edge also, a home edge also centralized management, which helps in talking to the cloud infrastructure when it comes into picture. So centralized management type of architecture. A scoring manager, which is very rudimentary currently, but can be made more robust, more self-learning, and more better predictive. So a self-learning scoring manager, a good ML framework, which could be a companion which can be brought in and worked upon together. And we are open for any open source community members who are such robust features or platforms with them, so that we can co-work with them and make our platform more complete. So this would be a win-win situation for all the both the projects, both the open source communities as such. A cloud synchronization. Current collaboration we have with edgex. We have also talked with OpenHorizon and Zedida for few things in last year, and we didn't take it forward ahead. But we are open again, and we are planning to revive our communications with them and see how well we can have a good collaboration along with these projects. So these are what we are trying to see, look for ahead in our journey ahead in HomeEdge. So that's it from me from HomeEdge. Hope stay tuned for our project, and you can see the GitHub details over here. The home wiki page, the Slack channel is there. do subscribe for the Slack channels. You'll get the notifications. Every month, first Tuesday, we have the call at 6:30 a.m. PDT, TSC call, the Technical Steering Committee call. We do request people to join the Technical Steering Committee so that to join the call, to make the platform more robust, to have a more harmonious collaboration of work together. So that's it from us, from HomeEdge. Hope I would have given some few details of HomeEdge. Thanks for joining us, and do contact us through Slack channel, and we are open to your questions and working together. Thank you.
Great. Thank you so much, Suresh and Arpit. This was a great presentation. Again, it will be available. The recording will be available on demand for viewing later. So stay tuned for those details. Anyone who registered will receive an email with that information. And we hope to see you all soon on another On the Edge with LFEdge webinar. Thanks so much. Have a great day.